Welcome to another video on my Raspberry Pi 1 using a Raspberry Pi camera and a webcam. Last time I decided not to use the XS motor from fischertechnik, which you can see here and here, but to focus a bit on pulse width modulation soft side software with these two coupled. Well, this one is out of the picture for the moment because this one is only applicable when powered, and I have taken the power off this hardware pulse width modulation circuit for the time being. Last time I also found that when I apply pulse width modulation, and as you can see the program isn't running at the moment, this program, so here's no flickering. So why is the LED on anyway? Because of this wire that I put alongside this op-amp, operational amplifier, with a wire to this LED. So now when I turn this pot meter up, this brightens or less bright, and this one goes the same. Do I run the program, then this one starts to blink in the written frequency, which is now at 15 thousandths of a second, which is visible with the bare eye, naked eye, and here it will be a different frequency visually, of course not really, not physically. So both respond to each other. Now the point is, of course, that while this works, this motor has some properties. Well, I have had some response on the fischertechnik forum regarding this motor, and actually not too surprising in values, because what I earlier thought that as used with the Arduino, the frequency was between 60 and 120. Well, the advice is to use between 100 and 200 hertz and not kilohertz. So the question is, how does that translate to pulses? And that is a very good question. Another point is, here are the dates, actually the data, the technical data of the motor. It says the voltage of the motor, the operational voltage is 9 volts, and then some more data which is not too relevant at this moment. Ampere, current, voltage, torque right here, and another torque with this is maximum efficiency and this is maximum performance. It is in German, written in German. Anyway, back to this. So let's run the program for now, and downside is that considering the memory and the processor on the Raspberry Pi 1, the the effects on camera will be different than you see now. So I start it, and well, you see it here blinking as if it is 1 or half a second, while it is very, very fast blinking with the bare eye. And it is exactly at the same time. Anyway, just like I told you it was. So now when I actually do this, it has no effect because of the pulse width modulation applied. So much for this. And then once again the question, okay, how to apply the frequency to the motor. For that I have to refer, yeah, that was a delayed thing, so you can see that when I do it some 6 seconds or even longer later, you will see it on here. And yeah, I was talking about the timing. So with, let's say 150 Hertz, what will be the ultimate thing? So using maxima for some calculations, when you have 150 Hertz and you want the periodic, then, or the time of periodic, then you divide it by 1 divided by 150. In floating point notation, you get well, rounded 67 thousandths of a second. And then going back to here, no, that's okay, this is the whole picture. The question is how to translate that 6 thousandths of a second into here. Well, this is millisecond, or was it microsecond? Okay, let's refresh memory then, because I think this was the wiring PI. This was the page I was looking for. It is alright, so it says microseconds apparently here. And what is this? Also microseconds. This is servo, this is PWM. And here it says clearly subcycle time in microseconds. Well, if you are talking about milliseconds, here also set a pulse increment in microseconds. Then you don't have to use, then you should not use 6000, but 6.7 in this case. So that's quite a difference. Okay, let's get everything back. So when this is microsecond, this should be actually 6.7 when talking about 150 Hertz. So let's go back here for a moment. Then we say, okay, 100, convert to float, which is obvious, and then 100, 200, and that is 0.05, which is also very obvious. But this means that this is 5,000 millisecond, and in microseconds it is 100,000. So this would be 5. So the maximum would be 5 actually. And what do we have here? 5. Going back is 100. That would be, yes, 10. So what do we have? 10. Did that work? No. That did not work at all. So now we are having the big question, if this did not work at all, how can we regulate? Because if the interval really is between 100 and 200 hertz, then I already had the settings. Looking here, I am looking at some moments that I put it in. So that should be something else. So just in theory, handling now. Setup is already there, or still there I should say. So taking this out, or in again, and how much time do I need? If that is already also so much milliseconds, I did this timing completely wrong. Which means in microseconds I should say 1 second or 2 seconds is 200. That is 2000. And then I run into a different problem, which is the maximum value, and that is 2. It is 1999, which is actually 2 seconds. So I should go from 1 to 1999 to have a visible exchange. So let's see how that is going to work out. So I changed the setup a little. First of all, I connected the motor. Then I took out the connection between this wire and this circuit, so this LED is no longer working. But I took that wire to re-establish the power between this circuit and the power line. So now is the question, will this work indeed or won't it? It may be that I have to put a delay in here, but let's see first if this is going to work anyway. Save. Yeah, this has no alright. Ha! Yes. And this is a problem because like earlier, this can only be 0 in this case. So this value is not possible. Can I diminish it with 1/10? Let's see. No, it cannot. 915. Oh, that is 915 of the yeah. No, this is not possible. Alright. 80 then, or whenever. Well, 1900 works. So let's just experiment now. Is this going to work? Yes, this is going to work. However, there's no sign of anything working, but there is no power here either. So the question is this alright? Let's see if this is somehow working. I don't think so. Alright, this is the big question. Where does it get its power from? That is a very good question right now. There's full power, no doubt, on this part of the circuit. On the other hand, let's raise some power. Alright. But then still, let's raise it to full power then. To make clear, there is power. But still, this LED does nothing. And that is suspicious. So, without power being here, there's no motor output, obviously. Am I doing something wrong in the code? Which is very well possible. You may notice that I tried something here earlier with a sleep time of 2 seconds, by the way. And 10 microseconds as in the example. But alright, let's quit this for a moment and set this up completely. What is the difference now, if any? Absolutely nothing. As long as this, as long as this part and this LED is not burning, there's no real power on the circuit. So let's make a measurement. And yes, that requires a multimeter. So the analog multimeter in place again, and the big question is, of course, what voltage is on the circuit. So well, this is no surprise. Okay, it's a little bit higher than 0. It's 1 volt or so, but this really matters. This is 4 volts, 4.5, almost 5 volts. So and 1 volt, is that enough to drive an LED? I would dare to think no, not really. And what is on this side of the circuit? 4 volts. What do I measure here? Barely enough. If I put the wire on it, this is still 1.5 volt, so that doesn't matter. This 1.5 something, taking it out, still 1.5 something, so that doesn't matter at all. And I'm a bit riddled. Why is this not really working right now? I didn't change anything to this part of the circuit. And without burning LED, I am absolutely not sure what's going on. This is a very low measurement. Very, very, very low. And yet, I think I did this correct. So yes, yet another riddle in the puzzle. The motor doesn't do anything. Well, it may do something, but it's not doing what I like, what I want to do. Oh, come on. Why is this happening? Stream goes. Now it's back. But is it really streaming? I can only try. Is this visible? Not really. Alright, streaming is off. Too bad. Restart streaming. Why is this happening? Well, if you've seen my videos before, you know that oopses do happen from time to time. And clearly this is no exception. Alright, next. what is next anyway? That is a good question. Final part of this video. For something to run, you have to have a potential difference. In this case, there must be a potential difference of at least a few volts. Now, measuring the excess motor, I'll try not to block the view to the multimeter. I'm probing here right now, and it says 5 volts. Very nice. What does it say here? 5 volts. There's no potential difference. It won't run. So, going here, starting the program. So, what's the difference? Is there any difference? Well, first of all, as I measured here, there's 1 volt. Here is 0 volt. That is not enough for making a potential difference, so this LED will stay off. Here there's 5 volts. Here now there is 5 volts. Here too. But now the pulse width modulation is acting, or should be acting anyway. Let's measure here. So let's put this transistor straight on, because if this isn't straight in its socket, it's not doing anything, and it won't do anything. I hope I don't break any wires. Anyway, this is giving a problem. Also, when I say okay, run, well, nothing is happening. So a big question is now, why is this circuit off? And to be honest, I don't have the answer. If I tap from this voltage, is there any difference? Well, this LED burns. This is still giving very little volt. This is giving a lot more. So here's already a question. If I measure here 4 volts, by which this LED works, what's going on here? That's a very good question. Right, enough for next time to figure out whatever it may be. So what did I do? First of all, again, examining with the wire intact how these LEDs correspond. Then with new found and received data, re-enabling these two lines, finding out that not everything works as it seems, but with this calculation finding out that everything is a millimeter or milli, and it should be micro, so this should 10 or well, whatever, 10 and whatever it was, 5 and 10. Would it work? Likely. Should it work? Yes. Does it work? No. Again, thank you for watching. If you like this video and my other videos, please subscribe to my YouTube. You can also follow me on Twitter and Instagram. Please visit my website listed at the start of this video and under this video for more information. And please donate to keep this blog going. Very much appreciated. And for more details on how to make a donation, please also see my website. Bye bye.